Hi class, this is Neil, and this is lesson 6 of unit 9 on Pythagorean identities. So in this lesson, what we're going to do is find other ways to solve for sine and cosine, really using a variation of the Pythagorean theorem. So the first thing that we're going to do in this video is look at how do we determine one of these Pythagorean identities. And really we're going to be looking at a proof of sort of the most common Pythagorean identity. All right, so we're going to go through this proof together. It's not something you would need to do in a Regents per se, but it's kind of important for you to see so that you know how it's being applied in other problems. So part 1 of the proof. Using the unit circle, sketch any reference triangle that intersects the circle at x, y. All right, I'm just going to draw that reference triangle in quadrant 1. So here is our point x, y. Here's our reference angle. And I'm just going to form our reference triangle from that angle. Now, kind of important to note here that because this is a unit circle, the hypotenuse is 1. My y value really represents the opposite side from that angle. So this side of the triangle is the same as the distance y. And my x value really represents the side that is adjacent to my reference angle. So the base of my triangle can be represented with x. All right, so part 2 of the proof. Use the Pythagorean theorem to create an equation that could solve for x and y. So remembering the Pythagorean theorem, it's a squared plus b squared equals c squared. C is always the hypotenuse. In this instance, the hypotenuse is 1. So I've got 1 squared. Now, doesn't matter what I use for a and b. I'll just write x squared plus y squared equals 1 squared. All right, so all I was supposed to do here is create an equation. Okay, so part 3. Determine the ratios for sine of theta and cosine of theta. So just as a quick reminder, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So using this triangle that I have here in my diagram, sine is opposite over hypotenuse. So we're going to write that as y over 1. Cosine is adjacent over hypotenuse. So we'll write that ratio as x over 1. Okay, so let's move on to part 4 of the proof. Solve for x and y in their respective equations from part 3. Well, hopefully you see that this is a pretty simple equation to solve in that I could multiply by 1 on both sides. It's really unnecessary, but we can still show it. And solving those equations, I'll get that y is equal to sine of theta and x is equal to cosine of theta. All right, so for part 4, use our results, or part 5 rather, use our results from part 4 to plug into our equation from 2. So here's our equation from 2. I'm just going to rewrite that equation here. X squared plus y squared equals 1 squared. Okay, so we know what x is. I'm going to replace x with cosine of theta. I'm going to replace y with sine of theta. Okay, now we've done a proof of the Pythagorean identity. So we see that based on where this reference triangle is, cosine of theta squared plus sine of theta squared equals 1 squared. Or really, cosine of theta squared plus sine of theta squared equals 1. So we'll come back to this in the next video, and we'll look and see how do we use this to help us solve problems.